Hello, discrete math fans. So now we're on to talking about proofs. And this chapter will be divided up into several sections that will introduce different concepts about proofs. In this section, we're going to just introduce a few basic concepts. The first of which we really want to talk about is some elementary properties of positive integers. First, we want to give some definitions. Now, you're going to be familiar with these definitions, but we want to make sure that we understand the precise definitions. So let's define an integer to be even, provided that it is equal to twice some integer. And an integer will be odd, provided it is equal to twice some integer plus 1. Now, if you want to write this in symbols, we'll say that n in the integers is even if and only if n is equal to 2k for some k in the integers. And n in the integers is odd if and only if n is equal to 2k plus 1 for some k in the integers. Now let's ask a few questions. Things like this. Is 0 even? If a and b are integers, is 6a minus 8b plus 11 even or odd? How about negative 75? Is it even or odd? Is every integer, does it necessarily have to be even or odd? Could you have sort of a nothing category? And you might say, well, no, there's no nothing category. But remember, think about things like primes and composites. 1 does not fall into the category of either a prime or a composite number. So it's sort of nothing. Maybe the same kind of thing happens with even and odd numbers. Is it possible for a number to be both even and odd? All right, 0 is even because 0 can be written as 2 times some integer. In fact, 0 is equal to 2 times 0. 6a minus 8b plus 11 is odd because we can write 6a minus 8b plus 11 as 2 times 3a minus 4b plus 5 plus 1. And this number here, 3a minus 4b plus 5, is an integer. In part C, we can say that negative 75 is odd because negative 75 is equal to 2 times negative 38 plus 1. And finally, it is true that every integer is either even or odd. There's no other category like there is with primes and composites. But it's also true that they can't be both. It's not possible for a number to be both even and odd. Now, I don't want you to just walk around saying, oh, well, this is obvious. Everybody knows this. Well, this is something that we have to prove. And we're going to do that later when we get to something called the quotient remainder theorem. We're going to prove that every integer is either even or odd, and it's not possible for a number to be both even and odd. Okay, that's all for now.